Have you ever wondered about the limitations of our current internet communication systems? Let's dive into this intriguing subject. In today's world, the internet is our lifeline, connecting us from one corner of the globe to the other. But like all technologies, it has its limitations. The most significant of these is latency, the delay between the sending and receiving of information. Even in the age of high-speed internet, time lags are an undeniable fact of life. Think about the last time you video called someone halfway across the globe. Remember the glitches, the delays, the echoes? That's latency at work. Then, there's the issue of security. In a world where data is the new gold, the internet can sometimes feel like a battlefield, with hackers and cybercriminals constantly on the prowl. Confidential information is at risk of being intercepted and misused, leading to breaches of privacy and financial losses. The existing internet infrastructure, while robust, is not impervious to these threats. Lastly, let's talk about data transmission. Currently, traditional binary data, represented as ones and zeros, is transmitted over the internet. This method, while effective, is not the most efficient. The sheer volume of data being generated and shared in our digital age is staggering, and our existing systems are struggling to keep up. These limitations paint a picture of an internet that is, for all its benefits, still a work in progress. But don't lose heart. The world of technology is one of constant evolution and innovation. The future, however, holds something more promising: the quantum internet. It's a concept straight out of a sci-fi novel, but it's closer to reality than you might think. Quantum internet is set to revolutionize the way we communicate, promising unparalleled speed, unbreakable security, and a quantum leap in data transmission capabilities. But that's a story for another time. Stay tuned as we explore this exciting new frontier in our next segment. So, what exactly is this quantum internet, you may ask? Well, imagine an internet that's not just faster, but more secure and robust than anything we've seen before. This is the promise of quantum internet. In the traditional internet, information is sent in binary bits, zeros and ones. But in the quantum internet, we use something much more intriguing: quantum bits or qubits. Unlike binary bits, which can either be a 0 or a 1, qubits can exist in multiple states at once. This property is known as superposition, and it exponentially increases the information that can be carried by each qubit. But the magic of quantum internet doesn't stop there. It also promises to be more secure. In the world of quantum physics, we have a phenomenon called quantum entanglement, which allows two qubits to be linked no matter how far they are from each other. If you change the state of one qubit, the other one changes instantaneously. This means that any attempt to eavesdrop or tamper with the information being sent will immediately be noticed. It's like having a communication channel that is, in theory, unhackable. Now think about the implications of such a system. Instantaneous communication, regardless of distance, unprecedented levels of security, the ability to perform complex computations at lightning speed. This could revolutionize everything from banking to healthcare, from military operations to space exploration. The quantum internet largely owes its existence to the McGinty equation. This equation, in its various forms, represents the interaction of quantum fields and gravitational forces. It's a complex beast filled with terms like psfractal, psgravity, and VYT that denote different aspects of quantum field behavior under various conditions. But you don't need to understand the mathematics to grasp the potential of what it can do. Sounds complex, doesn't it? But don't worry, it all comes down to a fascinating concept known as quantum entanglement. Quantum entanglement sounds like something out of a sci-fi movie, but it's very real. It's a phenomenon that defies our everyday understanding of the world. It's a kind of spooky action at a distance, as Albert Einstein once put it, where two particles become so tightly knit that they essentially share the same existence. To understand this better, let's imagine you have a pair of magical dice. No matter where these dice are in the universe, every time you roll one, the other one always shows the same number instantly. This is the magic of quantum entanglement, where the state of one particle instantly influences the state of the other, regardless of the distance between them. The McGinty equation, a significant breakthrough in the field, helps us understand this quantum connection between particles. It's a complex formula that delves into the world of quantum field theory and fractal mechanics. But for our purposes, it's enough to know that this equation helps explain how quantum entanglement works. Now, this might seem like an abstract concept, and you're probably wondering, what does this have to do with the internet? Well, this is where it gets exciting. The unique properties of quantum entanglement are what make the concept of a quantum internet possible. Imagine being able to send data across the globe instantaneously with no risk of it being intercepted or hacked. This is what quantum entanglement-based communication promises. A single change in a quantum state here could instigate an immediate change in a quantum state on the other side of the planet or even in outer space. This could lead to a new era of secure, instantaneous global communication. The quantum internet is still in its nascent stages, but the principles of quantum entanglement, which we've barely begun to explore, have already started to influence how we think about communication, security, and data exchange. We're on the brink of a revolution in information technology, all thanks to this seemingly esoteric quantum phenomenon. The potential of this technology is immense, and it's paving the way for global quantum communication. Global quantum communication, a new era of secure and instantaneous global communication. Picture this, a world where qubits, the fundamental unit of quantum information, are transmitted across vast distances in the blink of an eye. The magic of quantum entanglement ensures that this information exchange is unhackable, revolutionizing the way we transmit data. Now, let's take it a step further with the simplified McGinty equation. This groundbreaking formula represents the perturbative effects of gravity on the quantum field, adding a new layer to our understanding of quantum communication. The fractal potential term, with its self-similar fractal structure, further ensures the integrity of quantum communication, making it not only fast, but also reliable. The advent of quantum internet and global quantum communication is not just a distant dream. It's a reality that's rapidly unfolding, thanks to the relentless pursuits of quantum physicists and engineers. The future of internet communication is quantum, and it's closer than we think.